Let's discuss the question number 10, which is from test 3 engineering mechanics EM. Okay, so a truss structure is given and the load is applied on one of the joint as shown. So let's draw the truss structure where A is basically a hinge. The pin A is hinged, and B there's a roller, and at C, so basically 3 links are connected by means of this, forming a triangular structure, and 1 Newton is applied on pin C. And what is asked is how much is the load that is developed in this member AB. Okay, so this is a truss structure, and let's use the method of joints. So method of joints means just consider the pin, each of the joint, and put the forces acting on each of the joint, and then let's find out what is asked. So let's consider joint C here. So on joint C, 1 Newton is applied. Now because of AC, let the force on pin C because of the member AC be something like this, FAC, and because of BC it can be like this. Now directions are purely based on your intuition. You can put FPC reverse of what I have kept, but then once you solve, you will be getting the negative value instead of the positive value. So directions are purely based on your choice. You can just put as either like this or just the reverse of what I have kept. So FAC and FPC, because I have kept in such a way such that it balances this 1 Newton. If you just take the resolve FPC, it should balance in 1 Newton. So based on that, I have just kept in this, but it's this, you can keep it in any direction, and once you solve, you will get the result. Okay, so because it's a equilateral triangle, so each of the angle is 60. Okay, so this angle is because this will be 30, this will be 30, and this is 60 and 60. Okay, and now let me put my coordinate axis as x and y. So because joint C, each of the joint is in equilibrium or static equilibrium because it doesn't move. Okay, the pin is in static equilibrium, so I can write sigma fx as 0 and sigma fy as 0. So these two equations I can use because it's the pin is basically a small object. Okay, so sigma fx, if I use, so it will be 1 minus FPC cos 60. If you resolve FPC, the direction is minus, and FAC is also in the minus way, and if it is FAC cos 60 equal to 0. So this will this end up giving 1 is equal to FPC cos 60 plus FAC cos 60. Okay, now when I use sigma Fy is equal to 0, so I have let's put the upward direction as positive. Let's take upward direction as positive. So it will be FPC cos 30 plus, and then minus FAC cos 30. I am resolving FAC cos 30 in this way, so it's downward, so it's minus. Okay, so based on this, I will get FPC is equal to FAC, and when I plug in this way, so I get FPC is equal to FAC, and that is nothing but 1 Newton from this equation. So okay, now what is asked is FAB. So I can consider joint A or joint B, but joint A will have 2 unknown reactions. So let's consider joint B for simplicity. Okay, so joint B, because FPC on C, it applies a reaction force like this. So the member BC, if you consider only member BC, the forces will be like this. It will be in compression, and what we got, the values are 1 Newton. So on joint C, because of link FPC, will be just the reverse of this. So it will be like this. This is joint B, and now because of FB, let me put it in this way, and because of the roller, there is a reaction R vertical. So there are these 3 forces, and then now again consider sigma Fx 0, sigma Fy 0. So I can consider either of these, but if I consider sigma Fy 0, I'll have the unknown force unknown reaction R. So let me just consider only sigma Fx0, and this angle is 60. So if I consider this, taking my x like this and y like this, so in direction of x, whatever the forces are there, I'll take positive, so it will be FPC cos 30 minus FAB. There are no other force in the x direction. The R is vertical, so it doesn't produce any component. So FAB is basically FBC cos 60, and FPC we got 1 Newton. 1 Newton into cos 60 is half, so it is half Newton. So now half Newton is basically the load on the tension on the member AB. So member AB, so because on joint B the AB exerts a force towards left, so because of the pin on the member AB, the force will be like this. This is just Newton's third law. Okay, and now for link AB to be in equilibrium, it will be like this. So the load is tensile and the magnitude is half. So the option is B. Thank you.